This is the last in a series of videos showing the work necessary on this, which is a Pollard 15Y pillar drill, probably built in the 1950s. Here the auto feed gearbox is being remounted on the machine, followed by the quill. As the drill has a manually adjustable drilling platform for the work, first the gearbox and then the quill are rested on the platform and raised into position using the hand wheel.
The gearbox using the platform, it's just in, reach the limit, lock it up with wood and start again. The shaft is just in, there's a bit of taper on the end. It's no more than a hand size. There's no difference.
The quill is fitted in the same manner as a gearbox by resting it on the platform, then slowly raising the platform to feed it into the gearbox. What looked a simple job actually took up to an hour, as the quill refused to go in for one reason or another, and eventually just went in when I wasn't looking.
Quite sure what happened then. One minute it wouldn't go through, and the next minute it would. Something must have lined up.
By this point I was definitely considering the advantage of having a motorised platform rather than a hand wheel operated one. Still, it probably won't be used as much as this in future. Having partly disassembled the feed gearbox again to try and get the quill in, it can now go back together, but a couple of marks needed addressing on the pinion.
There's two marks on the pinion. You can see this is the area where the teeth actually mesh with the quill. This is from a needle roller bearing that I found jammed in the back of the teeth on the quill. This I haven't seen before, but I'm going to make sure that these two are filed down nicely.
With the high spots addressed, the pinion could be reinserted and the feed gearbox reassembled. The traditional method was used to make a gasket using a ball peen hammer. The drive shaft that rotates inside the quill then needed a coupling ready for another drive shaft that will connect it to the rotational 9-speed gearbox at the top of the drill. A good selection of roll pins is a definite must for working on one of these machines. After the coupling, the thrust bearing that pulls the shaft up into the taper roller bearing at the bottom of it should be adjusted. I haven't shown this as I forgot to do it at this point. The next coupling is one for which a bicycle type chain is attached, which goes up and round to the back of the drill with a number of counterweights to raise the drill again after it's been lowered by hand. You can see here that the counterweights don't raise the drill as they should.
Making a placement for this to go on the top of the shaft, the very top of the drill. Can't see it here. This looks as if it might have been turning on this face. Make it a couple of thou bigger.
Just visible here is not swarf coming off the cutting tool, but a mixture of oil coming out of the oil light and the brass, which looks like a liquid full of glitter, really. The tailstock of the lathe was then removed to allow the shaft to be presented to the bush and the fit checked.
Not sure how far that's going in. To the length.
The oil light that this bush is made of is sintered brass or sintered bronze, which is forced full of oil. To fit the bush in what is quite an awkward place to get to, I made effectively a slide hammer. This is the sliding part. It will slide on the actual shaft.
The idea is to put the shaft in place with the bush on, and then knock it into place with this. That should be long enough so that it doesn't hit the casing on the top of the drill. That well, the bush isn't turning anyway. Sounds solid to me. Just got to line the shaft up. This hole and that hole.
You can clearly see here the chain that connects the quill to the counterweights at the back of the drill. What's obvious now is that I've connected it wrongly. It's at 45 degrees to the quill, and pulling it to the side like this prevents it from moving properly. It should have gone over a pulley directly above my hand so that the chain came down square.
I can pull this.
This took a while to find out.
I see that dropped. It is the big chain. It dropped without that.
Oh, I see what you mean.
It was the chain.
What the hell is that tight on then? Is that chain in the right place? I'm not being funny. It's not supposed to go down that up there, is it?
Well, you're possibly.
Because when you got it out there, it's pulling
It's
sideways.
a steep angle, isn't it? Yes. I think you might be right.
What else is that for?
This rod. Oh, it's a pulley
No,
there.
a little pulley, yeah.
Yes.
Yeah, that's what it's for. That's what it is, isn't it? It's
Ah, yes.
wrong.
I have to include you in my video now. Well, I found out fine.
Yeah, ladies and gentlemen.
Right.
I didn't realise you were filming all that.
So with the troubleshooting completed, this shot demonstrates that the three feed speeds are now working. 0.25, 0.18 and 0.1 millimeters per revolution. which is great. That was the whole object of disassembling this thing. The effect of the new bush in the top gearbox can also be seen now, as the shaft that you can see above the gearbox used to wobble from side to side, and now it's fine. The other reason for disassembling this was that there was play, about 6 or 7 thou in the quill. You can see here that
Just over half a thou in each direction.
3/4 of a thou each way, which is a lot better than it was. It may even be tunable to remove that. I'm happy with the way this has turned out, and it's a very useful tool to have in the workshop. And thanks for watching.